Okay, so let's go over the review really quickly. Make sure you watch this. If you do not understand it, come in and ask for some help. All right, so we need to identify the sequence as arithmetic, geometric, or neither. Remember, arithmetic, you're adding or subtracting a number each time. Geometric, you are multiplying or dividing each time. Neither means that there may be a pattern, but we just don't know what it is. Okay, so thinking, how would I add or subtract to get from 14 to 11? Well, it looks like to me we would subtract 3. And then here we would subtract 3. So that is the definition of an arithmetic sequence, and our difference is minus 3. Let's go on to number 2. If I were adding and subtracting, this would be plus 6. This right here, well, that's not plus 6. Okay, so I don't even have to continue considering that. Let's think about multiplying or dividing. To get from 3 to 9, I would multiply by 3, by 3, by 3. Hallelujah, here we go. This is geometric, and my R value would equal 3. Okay, let's see here. My tip for you here was to change everything into fractions if you needed to. Okay, let's think about how would I get from 2. Automatically I know that this cannot be arithmetic. Think about why. I know that this can't be arithmetic because I'm going from a positive number to a negative number to a positive number to a negative number. You're not going to be able to add or subtract the same number and keep switching back and forth like that. So let's hope that this is geometric. How would I get from 2 to negative 1? Well, I would divide by a negative 2. Negative 1 divided by negative 2. The negative and the negative will make a positive. 1 divided by 2 gets a half. Oh, hallelujah, here we go. This is a geometric sequence. With my R value, I'm dividing by negative 2. So when you divide by negative 2, that's the same as multiplying by negative 1/2. All right, number 4, I would add 3, add 5, that's not arithmetic. I would multiply 2 to 5. Remember my trick. If you can't think of what it is, it's next divided by previous. So this would be 5 divided by 2. Okay, next divided by previous, that's multiplying by 2. Okay, this isn't geometric or arithmetic, so this would be neither. There may be a pattern, but it's not arithmetic or geometric. Okay, let's go on to the next one. Here, I would add 5, there you go, that one was pretty easy. This is arithmetic, and our difference is plus 5 each time. Over here, I would, what is that, subtract 3.6, not subtract 3.6, okay, here. I see the pattern, but again, if you do not know what it is, you do next divided by previous. Look at that, negative 0.1, or that's negative 1/10. Okay, so I just did that in my calculator, next divided by previous. So this is geometric, and your R value is a negative 1/10. Okay, refer back to your 11.1 through 11.3 notes. This kind of comes from all of them. Write the first 4 terms in a sequence, assuming that n begins with 1. So a sub 1. Remember what that means is that you plug in this n value for your n. So 3 times 1 would give you 3. 3 plus 4 would be 7. A sub 2. You're plugging in 2 for n. 3 times 2 is 6. 6 plus 4 gives you 10. A sub 3. 3 times 3 is 9. Plus 4 is 13. And one more. A sub 4 equals, well, 3 times 4 is 12. 12 plus 4 is 16. So the first 4 terms, would be this. Okay? Same thing over here. We need to find a sub 1, a sub 2, a sub 3, and a sub 4. Now remember, I did teach you how to do this in the calculator. All you would have to do is put the function that I give you in y equals n over 4x squared, and then go to your table and it will plug in 1, 2, 3, and 4 for you. So a sub 1 would be 1/4, a sub 2 would be 1/8, a sub 3 would be 1/12, and a sub 4 would be 1/16. Okay? All right, let's keep it going. An arithmetic sequence with this. Notice that this is still the instructions 7 through 10. So there you go. So all I'm supposed to do is list the first 4 terms. Well, I tell you what the first term is. And how do you get to the next term? Well, your common difference is -4. So 28 minus 4 would give you 24. Subtract 4 again, that would give you 20. Subtract 4 again, and that would give you 16. There would be your first 4 terms. Geometric series is the same way. Okay, I told you the first value. To get to the next value, you multiply that by 1/4. Well, multiplying by 1/4 is the same thing as dividing by 4. So 84 divided by 4 would give you 21. Okay, then we divide by 4 again. I'm just going to put 21/4. You could find the decimal if you wanted. Divide by 4 again, and that would give you 21/16. Okay. Again, if you wanted to put that in your calculator and get decimal equivalencies for that, that would be fine. All right, find the indicated term of the sequence. Here I'm wanting you to find out what a sub 22 is. So all you have to do here is use this as your n value here. Okay. So I am going to find a sub n, or a sub 21. That's a 22. Sorry, kids. So that's -1 to the 22nd times 4 times 22 minus 10. I'm just going to plug that into my calculator exactly as I see it. -1 to the 22nd, parentheses, 4 times 22 minus 10, close parentheses. And you should get 78 if you entered that in correctly. Okay, next, find the 13th term. You could write a formula here. It's the geometric sequence. That's probably what I would do. Or you could figure out what the common ratio was and just continue multiplying it out. I'm going to go ahead and write the formula. So the general form for a geometric formula is a sub 1 times your common ratio to the n minus 1th power. Here's my a sub 1. And then how am I getting from one term to the next? Looks like to me I'm multiplying by 3, by 3, by 3. So a sub n is equal to 5 times 3 to the n minus 1. Well, I need n to be 13. So I'm going to plug in a 13. 5 times 3 to the 13 minus 1. Okay, plug that into your calculator. 5 times 3 to the, that'll eventually be the 12th power. Get a pretty large number here. Your 13th term is 2,657,205. Okay. Feel free to pause the video at any time and make sure you understand that. If not, look back at, for geometric notes, look back at your 11.3 notes. All right, find the formula for the sequence. So 13 through 16, that's the instructions that we're using. Okay. Well, if this is an arithmetic sequence, remember we start out with a sub n is equal to a sub 1 plus n minus 1 times your common difference. I have my first term, I have my common difference, I just need to plug that in. So a sub n is equal to, have a good day, 8 plus n minus 1 times my common difference. And that's not very pretty. I do want you to distribute this out and simplify it into a linear function. So when I distribute here, that's going to give me a sub n is equal to 8 plus 4n minus 4. So when I clean that up, I have a general formula as 4n plus 4. That's how I want you to write it on the test, please. Next one. The arithmetic sequence 5, 13, 21, 29. Again, we're still finding the formula. I told you it was arithmetic, so we're using the same formula here. Remember, you will have that provided for you on the test. Here's my a sub 1. My common difference isn't given, so you have to find it. How do you get from 5 to 13 or 13 to 21? Looks like to me our common difference is plus 8. So let's plug everything in. A sub n is equal to 5 plus n minus 1 times our common difference. Again, I will take off if you leave it in this form. I want it distributed and simplified. So this is 5 plus 8n minus 8. So a sub n is equal to 8n minus 3. Remember, the importance of that equation is that you have a general formula to find any term that you want. You don't have to continue following the pattern. Let's move on to geometric sequences. Okay, remember that the general formula here is a sub n is equal to a sub 1 r to the n minus 1. I have my first term here. What do I need to multiply by to get to the next term? Well, remember, the easy way to do that is next over previous. So 2 over 4 would simplify to a 1/2. So a sub n is equal to my first term, which in this case is 4. The common ratio that I'm multiplying by is 1/2, and I'm raising that to the n minus 1th power. Final answer. Geometric sequence, I make everything easy for you here, but a lot of you have been freaking out about this e. Okay, remember, e is just a number. If you need to remember what that number is, you can do second division symbol, and it tells you that decimal approximation for e, the natural number. So we're just going to plug this into the formula. A sub n is equal to 5.5 e to the n minus 1. That's it. Don't freak out about it. For 17 through 24, so it's going to be on the other side, we need to find the sum, rounding to 2 decimal places where necessary. You can check your work. So remember, math 0, you can check your work here, but you need to show your work to earn full credit. If you just have the number, I will count off. Okay? Now here, this looks like an arithmetic sequence to me. Down here, I tell you that it's an arithmetic sequence. So if you know for certain it's arithmetic, you can use the summation formula for that. But personally, I'm going to play it safe if I don't know what it is, and I'm going to find them manually. Okay, I'm going from 1 to 4. So notice I have a sub 1 to a sub 4. If I plug in a 1 here, I have 3 times 1, which is 3. Subtract 2, that's a 1. Plug in 2. 3 times 2 is 6. Minus 2 is 4. Plug in a 3. 3 times 3 is 9. 9 minus 2 is 7. And finally, 3 times 4 is 12. 12 minus 2 is 10. Remember that this sigma symbol means that you are going to sum all of these up. So 10 plus 7 gives you 17. Plus 4 is 21. Plus 1, 22. Over here, this is not arithmetic, and it's also not geometric because the variable is not the exponent. So again, I'm going to do this by hand, but notice that this starts at 0, not 1, so we can't use any of our formulas anyway. A sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. We can do those by hand, or I would like to remind you that you may use your calculator. 5x squared, go to your table. A sub 0 is 0, so I'm just going to read these off here. This is 0, 5, 20, 45, and 80. Add those up quickly. 80 plus 45 plus 20 plus 5. The sum for this series is 150. Okay. A finite arithmetic sequence. Okay. This one I am telling you that it is arithmetic. So we know that we can use our formulas. Look here, I even named it for you. The sum of a finite arithmetic sequence. So we're using this formula. Okay. The sum of 1 to 90 of 6n plus 2. So if we are using the sum formula, n over 2 times a sub 1 plus a sub n, I want to remind you what each of these pieces means. N is the number of terms that you will eventually get to from 1 to 90. You all get confused about this. Remember, 0 to 9 is 10 terms. 1 to 10 is 10 terms. We'll get started in just a second, sorry. Okay, but if you are going from 0 to 0, that's actually 11 terms. Or if you're going from a 1 to a 1, that's actually 11 terms. So the number of terms between 1 and 90 is 90, so that's going to be our n. It's not just whatever that top number is. Be careful about that. We have to figure out what a sub 1 is, and we have to figure out what a sub n is. So here, the sum of the first 90 terms of this sequence would be 90 divided by 2. A lot of you have just been putting 1 here and 90 here, and that's why you're getting every one of them wrong. Okay? You actually have to figure out what your first term is by plugging in 1 to the rule. So 6 times 1 would give you 6. 6 plus 2 would give you 8. Then you have to figure out what your last term that you'll evaluate is. So 6 times 90 would be 540. 540 plus 2 would be 542. Put that into your calculator exactly as you see it. Alpha y equals 1, 90 over 2, parentheses, that would be 560. Nope, 550. Good chat. So your final sum here would be 24,750. Now, good kids are going to take the time to check themselves in their calculator. Math 0, you're going from x to 1, 90. Your rule is 6x plus 2. And if those numbers match, you know you did it correctly. But that will not suffice as a correct answer. If you just put that, I do need to see your work. Moving on. Sorry guys, I'll be done in just a second. I have a sub tomorrow, so yeah. Okay, so here we go. Finite arithmetic sequence. We're using the exact same process. We're going from a 1 to a 0, so I know that that will be an increment of 10. And here is my rule. So the sum of the first 40 terms is equal to 40 over 2. My first term, I cannot just put a 1, I have to plug it in. So 3 times 1 is 3, minus 1 would be 2. Then add it to my last term, plug in 40. 3 times 40, hold on, yes. Okay, let me stop this video then.
Oh my gosh, I didn't know you were recording.